Have you ever wondered how the seemingly abstract lines of "could you write" actually become the precise electrical signals that bring a microcontroller to life, allowing it to control devices or perform complex tasks? A microcontroller build system functions as a carefully orchestrated toolchain, transforming your human-readable source code into an executable binary firmware that can be directly loaded onto the microcontroller's memory. At its core, this process involves several distinct but interconnected stages, each designed to convert code written in high-level languages like C or C++ into machine-specific instructions understood by the central processing unit of the microcontroller. The journey typically begins with a preprocessor which handles directives, followed by a compiler that translates the high-level code into assembly language, an assembler that converts assembly into object code, and finally a linker that combines all compiled modules and libraries into a complete executable image. This systematic approach ensures that all dependencies are resolved and the code is optimized for the target hardware's architecture. To make use of this system, you generally write your code in an integrated development environment, or IDE, which often bundles all these tools. When you hit the build or compile button, the IDE orchestrates the entire sequence. It calls the necessary tools in the correct order, taking your project files and producing the final firmware. This firmware is then often converted into a specific format, such as a hex file, which is easily programmable onto the microcontroller itself using a dedicated programmer device. Understanding these internal workings reveals why microcontroller development often involves specific compiler flags, linker scripts, and memory maps. These elements are crucial for guiding the build system on how to arrange code and data within the microcontroller's limited memory resources, handle interrupt vectors, and manage peripheral register addresses efficiently. Without this granular control, optimizing for performance and memory footprint in embedded systems would be virtually impossible, highlighting the intricate relationship between software and hardware at a fundamental level. Ultimately, the microcontroller build system is the essential bridge that translates your high-level programming intent into the low-level operational reality of embedded hardware, ensuring that every instruction and data bit finds its correct place and function. It provides the structured, reliable pathway necessary to transform abstract ideas into functional, real-world applications, making complex embedded programming accessible and manageable.